हेलो एवरीवन। आज हम लोग सीखेंगे बाइनोमियल डिस्ट्रीब्यूशन। So see, we have studied about discrete random variable, and if you have not seen that video, so the video name is mean and variance of random variable. Go and see that video first, then come to this. So we have seen that discrete random variable and its probability distribution, and this binomial distribution was discovered by James Bernoulli in 1700. Okay, this distribution has been used to describe a wide variety of process in business and social sciences as well as in other areas of science and technology. In binomial distribution, a random experiment is performed repeatedly under identical conditions, and the distribution determines the probability of occurrence of one set of dichotomous alternatives, and that is success or failure. Okay, so let us see first what is Bernoulli's trials. See, Bernoulli's distribution is based on only one formula, and its sums are also easy, but before that we have to know what is Bernoulli distribution and what is its practical application. Only then this chapter will be interesting. So first of all, see what is Bernoulli's Bernoulli trials. Okay, so if you observe, we come across many experiments which are dichotomous in nature, that is success and failure. Okay, in nature, that is they produce one of the two possible outcomes in a trial. If you take example, when we toss a coin, it shows either head or tail. A manufactured item can be defective or non-defective. That is, in such type of experiments, it is customary to call one of the outcomes a success and the other outcomes as a failure. If this type of experiments are repeated under identical conditions, then the outcomes of any trial is independent of the outcome of any other trial. In each of such trials, the probability of success or probability of failures remains constant. Such independent trials which have only two outcomes, that is success or failure, are called Bernoulli trials. Okay, so we can define it as trials of a random experiment are called Bernoulli trials if they satisfy the conditions. Number one is they are finite in number. Number two is they are independent of each other. Number three is each trial has exactly two outcomes, that is success or failure. Number four is the probability of success or failure remains same in each trial. So if we take one example, if 4 balls are drawn successively with replacement from a bag containing 7 red and 6 black balls, then the probability of getting a black ball in each trial remains same, right? We have 7 red and 6 black balls, so we have total of 13 balls, and from that 13 balls we have to take 6 black balls. Okay, getting a black ball, that means 6 by 13. So trials are Bernoulli trials. If the balls are drawn successively without replacement, then the probability of getting a black ball in first trial is 6/13. In the second trial is 5/12. If the first ball drawn is a black, or 6/12 if the first ball drawn is a red, and this will continue. Okay, so I think you have come to know what is Bernoulli trials. It follows some conditions. Okay, it's mainly about success and failure and equally probable. Now, Bernoulli distribution. Okay, so first of all, we have to meet the basis of Bernoulli distribution. So let's see binomial distribution. Binomial distribution. So let us consider a random experiment and an event A associated with it. If the experiment results in the event A, let us call it a success denoted by S. If on the other hand, if the event A does not occur, let's say that the experiment has failed, and that failed experiment is denoted by F. Okay, and let probability of success P of S is small p, and probability of failure is Q. Then success and failure should be 1, right? So P plus Q should give 1. And let us say this experiment is performed 4 times under identical conditions. So let the experiment is performed 4 times under identical condition. Okay, and we want to find the probability of 3 successes. Okay, so that means 3 success in 4 trials, right? So 3 success in 4 trials can occur in 4C3 mutually exclusive ways. Okay, so that means 3 success in 4 trials. How can it happen? Success, 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 failure, success, failure, success, success, failure, and then success. 2 success, 1 failure, and 1 success, right? In this manner, 3 success and 1 failure can happen out of 4 trials. So by addition theorem of probability, we can have probability of 3 successes in 4 trials, that is probability of SSSF plus probability of SF SS plus probability of FSSS plus probability of SSFS. Okay. Now, since 4 trials are independent, 4 trials are independent. Okay. Therefore, multiplication theorem for independent events, we can say if 4 trials are independent, we can say P of SSSF should be P of S, P of S, P of S multiplied by P of F. We know PS is P and PF is Q. So it would be P cube into Q. We can write it as P cube and Q to the power 4 minus 3. Similarly, we can have probability of success, failure, success, success. It should be P cube Q to the power 4 minus 3. In this manner, probability of failure, success, success should also be P cube and Q to the power 4 minus 3. And probability of SSFS will also be P cube Q to the power 4 minus 3. Okay. So we can say probability of 3 successes in 4 trials, that should be, we have to add all those things, right? So P cube Q to the power 4 minus 3 plus P cube Q to the power 4 minus 3 plus P cube Q to the power 4 minus 3 plus P cube Q to the power 4 minus 3. So we can say 4C3 P cube Q to the power 4 minus 3, right? This 4 can be written as 4C3 because 4C3 gives 4. Okay. And proceeding in the same manner, we can show that probabilities of 0, 1, 2 and 4 successes are given by 4C0. Here we have 3 successes. We have 0 successes, then it would be 4C0, P to the power 0 and Q to the power 4 minus 0. 1 success, that is 4C1, P to the power 1, Q to the power 4 minus 1. 2 successes, that is 4C2, P to the power 2, Q to the power 4 minus 2. And 4 successes, that is 4C4, P to the power 4, Q to the power 4 minus 4. Okay. Now let us say if X denotes the number of successes, so let X denotes the number of successes in 4 trials. So X can take values 0, 1, 2, 3 and 4 such that P of X equals to 0. We can define it as 4C0, P to the power 0, Q to the power 4 minus 0. That is 0 success. P of X equals to 1, that means 1 success. We can say 4C1, P to the power 1, Q to the power 4 minus 1. in this manner. P of x equals to 2 success, 4c2 p to the power 2 q to the power 4 minus 2, and P of x equals to 3, that is 4c3 p to the power 3 q to the power 4 minus 3, and P of x equals to 4, that is 4c4 p to the power 4 and q to the power 4 minus 4. Okay, so in other words we can say that P of x equals to r, if we assume, then it would be 4cr p to the power r q to the power 4 minus r, where r is 0 success, 1 success, 2 success, 3 success and 4 success. Okay, so this result can be generalized to the case where the experiment is repeated n times. Sorry, under identical conditions. Okay, so we can define binomial distribution as P of x equals to r ncr p to the power r q to the power n minus r, where r can be 0, 1, 2 up to n, p and q is greater than 0, and p plus q, success plus failure, should be 100%. Okay, now let us move forward. If n trials constitute an experiment and the experiment is repeated n times, then the frequencies of 0, 1 to n successes can be given as, so let me write this point here. If n trials constitute an experiment, n trials constitute an experiment and the experiment is repeated n times, then the frequencies of 0, 1, 2 up to n successes are given by n into p x equals to 0, n into p x equals to 1, n into p x equals to 2, in this manner. Okay, n into p x equals to small n. Now let us see one question. Question is, pair of dice is thrown 7 times. If getting a total of 7 is considered a success, what is the probability of number 1 no success, number 2 6 success, number 3 at least 6 successes, and number 4 at most 6 successes. Okay, so let's see how can you solve this question. So let P denote the probability of getting a total of 7 in unit, getting a total of 7. So let P denote the probability of getting a total of 7 in a single throw, of a pair of dice. Okay, so how can you get this sum 7? Sum 7. This can be 1, 6, 6, 1, 2, 5, 5, 2, 3, 4, and 4, 3. So P is the probability of getting 7. So you got 1, 2, 3, 4, 6 out of 36 set. So it would be 1 by 6. And we know P plus Q is 1, so Q would be 1 minus P. That is 5 by 6. Okay. Now let X denote the number of successes in 7 throws, right? Because we have thrown it 7 times. A pair of dice is thrown 7 times. 7 throws of a pair of dice. Okay. Now here X is a binomial variate with parameters n is 7 because we have thrown it 7 times, and P is 1 by 6. So we can say that P of X equals to R. We know the formula of binomial distribution. That is NCR, that is 7CR into P to the power R, Q to the power n minus R, that is 7 minus R. R can take value from 0 to 7. So first question is no success. So probability of X equals to 0, that means no success. So you have to put 0 in place of R. So it would be 7C0, 1 by 6 to the power 0, 5 by 6 to the power 7. So you will get it as 5 by 6 to the power 7. Okay. Now number 2 is 6 success. So that means probability of x equals to 6. So 7c6, 1 by 6 to the power 6, 5 by 6 to the power 7 minus 6. This value will comes up to be 35 into 1 by 6 to the power 7. So number 3 is at least 6 successes. So we can say at least, that is p of x greater than equals to 6. At least 6 and higher. So probability of x equals to 6 and probability of x equals to 7, because x can take values from 0 to 7. So 7c6, 1 by 6 to the power 6, 5 by 6 to the power 7 minus 6 plus 7c7, 1 by 6 to the power 7, 5 by 6 to the power 0. If you calculate, you will get it as 1 by 6 to the power 5. Okay, I am not calculating. Please calculate and recheck with the answer. Number 4 is at most 6 successes. So at most, that means maximum of 6 success can happen. So p of x less than equals to 6. 1 success, 0, 1, 2, 3, 4, 5, 6. Okay. So we can write it as, because for this we have to calculate 0, 1, 2, 3, 4, 5, 6. 6 values, 7 values. But we can write it as 1 minus p of x greater than 6. Right. So greater than 6 means we have only one value, right? That is 7. So p of x equals to 7. So it will be 1 minus 7c7, 1 by 6 to the power 7 and 5 by 6 to the power 0. So it would be 1 minus 1 by 6 to the power 7. This is the answer. So I think ये जो प्रॉब्लम है, ये जो क्वेश्चन है, ये तुम लोगों को समझ में आ गया होगा. Okay, and all these problems are actually formula based. You don't have to worry. Just apply the formula we have learned, and it will be very easy for you to apply, because we have only one formula, right? So let us see another question to clear your doubts. Find the probability distribution of the number of doublets in 4 rows of a pair of dice. So let's see the solution. So let us say that let P denote the probability of getting a doublet, getting a doublet in a single row of a pair of dice. Okay, so what would be P? It would be 6 by 36. Okay, so it would be 1 by 6 and P plus Q is 1. So that means Q is 1 minus P, that is 1 minus 1 by 6, is 5 by 6. Now here we have thrown 4 times. So our n is 4 and P we have calculated as 1 by 6 and Q as 5 by 6. So we can say P of x equals to R is probability of getting R doublets. Okay, so you know the formula 4CR 1 by 6, that is P to the power R, and 5 by 6 to the power 4 minus R, and we know R is 0, 1, 2, 3 and 4. Okay, now P of x equals to 0, so put R equals to 0 here. 4C 0, 1 by 6 to the power 0 and 5 by 6, Q is 5 by 6 to the power 4 minus 0. That means it is 5 by 6 to the power 4. Now P of x equals to 1, that is 4C1, 1 by 6 to the power 1, 5 by 6 to the power 4 minus 1, that is 3. If you calculate, the value would be 2 by 3 into 5 by 6 to the power 3. P of x equals to 2, this would be 4C2, 1 by 6 to the power r, that is 2, and 5 by 6 to the power 4 minus r, that is 4 minus 2 is 2. So you will get it as 1 by 6, 5 by 6 square. Now P of x equals to 3, that is 4C3, 1 by 6 to the power 3, 5 by 6 to the power 4 minus 3, that is 5 by 6 to the power 1. Okay, you will get it as 10 by 3, 1 by 6 to the power 3. Similarly, P of x equals to 4, that is 4C4, 1 by 6 to the power 4, and this is 5 by 6 to the power 4 minus 4, that is 0. It is 1 by 6 to the power 4. So what would be the probability distribution curve table? This would be 0, 1, 2, 3 and 4. So P of x is 5 by 6 to the power 4. We have calculated all the value. This is 2 by 3 multiplied with 5 by 6 to the power 3. This is 1 by 6 multiplied with 5 by 6 square. This is 10 by 3 multiplied with 1 by 6 cube. This is 1 by 6 to the power 4. Okay. So this is power 4. This is power 3. Now I think now you have a little bit of idea how to apply this type of question and how to apply binomial distribution. Okay. Now let us see mean and variance of binomial distribution. Mean and variance of binomial distribution. So remember this because we don't have the derivation in your syllabus. So mean of binomial distribution is n into p. Remember this. And variance is n p q. Okay. This is the mean. N into p is mean and npq is your variance. Now let us see one question to apply the formula. If the sum of the mean and variance of a binomial distribution for 5 trials is 1.8. Find the distribution. There is a question. So let's see the solution. So you know that mean is n into p and variance is npq. So it's given that n equals to 5, right? 5 trials. Sum of mean and variance is 1.8. So mean plus variance, it is given as 1.8. Okay. Now this should be np plus npq is 1.8. What is n? 5. So 5p plus 5pq, that is 1.8. Okay, and we know p plus q is 1. So q is 1 minus p. So we can say 5p plus 5p into 1 minus p is 1.8. So it should be 5p square minus 10p plus 1.8. That should be 0. Okay. Now if we take 5 common from this, so it would be p square minus 2p plus 0.36. This should be 0. And if we take middle term, it would be p minus 0.2, p minus 1.8, that is 0. Okay, so p cannot be greater than 1.8 because sum is 1.8, right? Mean plus variance sum is 1.8, so p cannot be 1.8, so p is 0.2. So thus we have n equals to 5, p is 0.2, and q is 0.8. Now let's assume that x denotes the binomial variate. Okay, so p of x equals to r, there should be 5 cr, ncr, 5 cr, p to the power r, that is 0.2 to the power r, and q to the power n minus r, so 0.8 to the power 5 minus r, where r can be 0, 1 to 5. Okay, this is the required binomial distribution. So this type of problem are very easy if you remember how to apply the formula. Okay, only formula based question will be there. So अगर ये वीडियो अच्छा लगा है तो तुम लोग लाइक करो, सब्सक्राइब करो और शेयर करो, और कमेंट्स में बोलो और कौन सा चैप्टर का, कौन सा टॉपिक का वीडियो चाहिए, फिजिक्स, केमिस्ट्री, मैथ्स, कोई भी सब्जेक्ट से. ओके, so that's all for today. Thank you and have a good day.